AI can do some absolutely incredible things these days. But how do we actually get all that power out of those giant, expensive data centers and onto the devices we use every single day? Well, that's exactly what we're digging into today, this fascinating art of shrinking AI through a process called model distillation.
So you've probably wondered this. We've got these incredible models, like GPT-4, but they're not running on your phone, are they? So what's the deal? What's keeping them locked away in these huge, power-hungry server farms instead of just running right here on our laptops?
Well, the simplest answer is they're just giants, absolute behemoths. We're talking about models with hundreds of billions of parameters. Think of them like digital brain cells. And all that power, it comes with a hefty price tag. They're ridiculously expensive to run and honestly way too slow for the kind of instant responses we all expect.
And that's exactly where this technique, model distillation, comes into play. The whole idea is actually pretty simple and kind of elegant, really. You take a massive, super smart teacher model, and you have it train a much smaller, leaner student model. The whole point is to pass on all that wisdom, all that knowledge, but without the enormous size and cost.
Okay, so let's talk about the AI shrinking problem. We've got this central challenge, right? How do you shrink these massive AI models without just losing all their power? It turns out, model distillation is one of the best answers we've got.
So why even bother? Why does shrinking AI matter so much? Well, for one, it means we can finally run some seriously powerful AI right on our own phones and laptops. For companies, it means slashing those server costs. And for you and me, that means faster responses and cheaper services. But really, the big picture here is about making the most advanced AI accessible to literally everyone, everywhere.
All right, so if the big model is the teacher and the small one's the student, what's actually on the syllabus? What is the student learning? This is where the whole process starts to get really, really clever.
Okay, so think about two different ways a teacher could answer a question. You could just give the final correct answer. You see a picture of a golden retriever, you say, "That's a dog." Simple. We call that a hard label. But a really good teacher, they give you what we call soft labels. They'd say something like, "Okay, I'm 90% sure this is a dog, but there's an 8% chance it could be a wolf, and maybe, just maybe, a 2% chance it's a fox." See the difference? And that hidden nuance, that rich, juicy information about how a dog also kind of looks like a wolf and a little bit like a fox, that's what researchers have this awesome name for, dark knowledge. It's not just about the right answer. It's the teacher's intuition, the context, the hidden relationships between ideas. And that is what makes the student model so much smarter.
And just like in real life, not all teachers have the same philosophy. You've got one approach, which is kind of like the know all possibilities teacher. It wants the student to learn everything the teacher knows, even the really unlikely answers. This can lead to a more creative student, but maybe a less accurate one. Then you have the other approach, master the best answers. This one is much stricter. The student gets penalized if it even guesses an answer the teacher thinks is impossible. This creates a super precise, super faithful student, which is perfect for things like generating text you can trust.
Okay, let's level up. We're moving past just teaching the student what the right answers are. Now we're getting into teaching models how to think. This is where distillation gets really powerful.
Think about it. It's not enough to just know the answer, right? The best students, human or AI, don't just memorize a bunch of facts. They learn the process. They understand the reasoning that gets you to the right answer.
So how do you do that? Well, there's this amazing technique called distilling step-by-step. Here's how it works. First, the big teacher model doesn't just give you the answer. It shows its work. It lays out a whole step-by-step rationale, its chain of thought. Then, the little student model studies both that method and the final answer. So what's the result? The student actually learns how to think like the teacher, not just copy its answer.
And get this, the results are just staggering. By learning how to reason, a student model with only 770 million parameters can actually beat its own teacher, which has a mind-blowing 540 billion parameters. It's not about size, it's about the quality of the teaching. That's a game changer.
All right, but this brings up a whole new problem. What happens when you're learning from secret teachers? What if the teacher is a closed book and refuses to share how it thinks?
And this is a real-world problem, right? How are you supposed to learn from a secret teacher like GPT-4? You can ask it questions, sure, but it won't show you its internal logic.
It won't give you those juicy, soft labels or that step-by-step reasoning. It's a total black box. So what do you do?
The solution is, well, it's pretty ingenious. You hire a tutor. If you can't get access to the master teacher directly, you find another model, one that's more open, and you have it study the teacher's methods.
This whole thing is called the Tutor Method, or Proxy KD. Here's how it plays out. Step 1. The secret teacher, like GPT-4, just gives a ton of answers. Step 2. The tutor, this other accessible proxy model, studies all those answers to figure out the teacher's style. And finally, Step 3. Our little student model learns directly from the tutor, who can give it all that nuanced knowledge it couldn't get from the secret teacher. It's a fantastic workaround.
Okay, so we've seen just how powerful and amazing distillation can be. It lets us create small, fast, super intelligent AI. But this whole process isn't perfect. There are risks, and that brings us to what you might call the Distillation Dilemma.
Let's just recap the promise here. You get powerful models that can actually reason, they're efficient, they're fast, and they make AI way more accessible for everyone. I mean, on paper, it sounds like the perfect solution, doesn't it?
But what if the teacher passes on its bad habits? Because here's the thing. When a student mimics a teacher that closely, they don't just learn all the good stuff. They pick up the flaws, the biases, all the bad habits too.
And the numbers on this are honestly pretty startling. Research has shown that this kind of distillation can actually degrade the safety of a student model by up to 50% compared to other methods.
So why does that happen? Well, remember all that dark knowledge we were excited about? When you force the student to mimic the teacher's entire brain, every single probability, even the tiny ones, you also force it to learn all the undesirable stuff. The student learns about the teacher's potential for bias, for harmful content, even if the teacher would almost never say those things. The student learns it all, the good and the bad.
And that really leaves us with a huge, crucial question to think about. Model distillation is without a doubt a key to unlocking AI for all of us. But as we get better and better at making AI smaller, faster, and smarter, are we also, maybe unintentionally, making it riskier?